Hi, this is the review preview problems from lesson 5.2.2. 5-73 says let y equals log base 2 times x, and then rewrite the equation so that it begins with x equals. So I made a side note here. So if you want to kind of look, and you can see the pattern of where everything goes, like the a, for example, here's the 2, and then what's in parentheses is going to be that x equals part, and then what was equal to is going to be our exponent. And there's another part down here that helps with that. We've got our base and an exponent, right? Okay, so when I look at this one and I want to rewrite it as an x equals, this becomes x equals 2 to the y power. And it does help to remember which part is the base and the exponent, or you can write this down if you want to as well. Okay, so looking at 5-74, so every exponential equation has an equivalent logarithmic form, and every logarithmic equation has an equivalent exponential form. So it shows us here how we'd rewrite them. If 4 is our base, exponent, here is 3, that's equal to 64. That's the same thing as we'd put our exponent on the other side here, and then log base 4. Okay, so it shows you where everything is. So fill in the missing table is what it wants you to do here. So take a second, pause the video, and see if you can rearrange these so they're in the correct form, right? So you're going to go back and forth between exponential form and logarithmic form. Okay, so I'm going to hope that you pause the video so you could at least try a few of these on your own. I'm going to go ahead and write in the answers so you can check. So I'm just moving everything around based on where it goes, looking at up above, okay? All right, so make sure you're checking your answers, fixing anything that needs to be fixed. Okay. Awesome. Let's go to the next one, 5-76. Okay, so it says, although the quadratic formula always works as a strategy to solve quadratic equations, for many problems it's not the most efficient method, which that's true. It does take a while. It is faster to factor or complete the square, even just outthink the problem. For example, for each question below, choose the method you think is the most efficient and explain your reason, then solve. Okay, we do have a quadratic formula here too if we need it. So for part A, I think it actually makes the most sense for this one to factor and do the zero product property. I don't think that the quadratic equation is the fastest because I can see that 8 minus 1 is positive 7, and 8 times negative 1 is negative 8. So I'm going to put a plus 8 and a minus 1. Do our zero product property. So x equals negative 8 and x equals 1. All right, part B, I actually think what's fastest here is to take the square root and undo that squared, because we've got this 49 here as well, which we can take the square root of pretty easily. So this becomes x plus 2 equals, and remember it'll be plus or minus 7. So x plus 2 equals 7, and x plus 2 equals negative 7. So x here equals 5, and x equals negative 9. Okay, part C is the quadratic formula, I think, because this one's a really tough one to factor, especially with that 5. So let's make A equal 5, B equal negative 1, and C equal negative 7. So if it helps, you can rewrite the quadratic formula down. That's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If it helps you to have this right there, otherwise it is right up above. Let me make it a little smaller. So let's start. We've got x equals, so we've got a negative 1 plus or minus the square root of negative 1 squared minus 4 times 5 times negative 7 all over 2 times a, which is 5. Okay, so we've gotten that far. Now that negative 1, we can make positive. Negative 1 squared minus 4 times 5 times negative 7, that ends up being 141 all over 10. And then I'm going to split it up. So we've got 1 plus the square root of 141 over 10, and 1 minus the square root of 141 all over 10. And in the calculator, like I literally will just do 1 plus the square root of 141 divided by 10. So that gives me 1.28. And then 1 minus the square root of 141 divided by 10, and that gives me negative 1.08. And you could always type in your equation into Desmos to see and make sure that these are both your x-intercepts. Okay, and for part D, I actually think we could complete the square, but I don't know how much of that we've done in our classes. So I think I'm just going to use the quadratic formula. So I'm going to add 1 to both sides. So we've got x squared plus 4x plus 1 equals 0. So A equals 1, B equals 4, and C equals 1. So with quadratic formula, that'd be negative 4 plus or minus the square root of 4 squared minus 4 times 1 all over 2 times 1, which gives us, I'll write it over here, that gives us negative 4 plus or minus the square root of 12 all over 2. Split that up, negative 4 plus the square root of 12 over 2, and negative 4 minus the square root of 12 over 2. And just type those in, right? Negative 4 plus the square root of 12 divided by 2 gives me negative 2.68. Negative 0.268, yeah. And then negative 4 minus the square root of 12 divided by 2 gives us negative 3.73. Okay. And then I think 5-77 is the last one we've got here. So it says if 10 to the 3x equals 10 to the x minus 8, then solve for x. Show that your solution works by checking your answer. And I did put a note here, because the numbers are being raised to a power that are the same, the exponents are equivalent. So what that means is we can actually just take 3x equals x minus 8 minus x on both sides, divide by 2, so x equals negative 4. Okay, but let's go ahead and actually check that so we can make sure it works. So I'll do the check here. So 10 to the 3 times negative 4 power equals 10 to the negative 4 minus 8. Okay, so that'd be 10 to the negative 12 equals 10 to the negative 12. And that works. Okay, that's all for this one. Thanks for watching.